Hello all, today we are going to discuss about the CX programmer for the Omron PLC programming. So I just want to go for the create a new project, and I'm using CP1E CPU, and just for the simulation I'm not doing the networking or the communication types, just hitting OK, and we have the programming section. First thing we have to discuss about the normal IO addressing for the Omron PLC. So the input contact is placed, and we have to address it as simply 0, okay, and hit the enter. And for comments I'm not using it, and hit OK. Now you can see I:0.00, that is the first address. It's up to 0 to 99, that is the input address, and we can go hit the output address. I just placed my coil right here and address it as 100. It is starting from 100. You can see it is 1.0, that is the IO addressing for the Omron PLC. And you can see if you want to create a branch or a rung, I can put a contact over here and name it as 100, enter, and you can see the same address has been created here. And if you want to a branch, have to press the control and hit the up arrow. So you can draw the up arrow like this, and if you don't want to, if you want to erase this, have to press the control and press the down arrow, the down cursor. Like this you can drag and create all this stuff, and this is it. And I'm going to place one NC contact right here for the dual connection, so that will be 0, and after that will be 1. So I:0.001, that is the second input address. And now we can go to run the simulation for watching all these things. So this is the simulation. You can start the simulation over here. The compiling will be automatically done, and if you have any errors, that will be mentioned on below. And if you want to run this thing, you can see the simulation window has been appeared over here. And if you want to run this thing, you can go hit the arrow and double tap on the contact or right click on the contact, and you can see set on. There is an option for setting the contact on. So I'm just double tapping on it, and you can see set the value as 1 and set. So you can see the output has been turned on. If you don't want this input, double tap, set as 0 and set. So that has been latched, and if you want to stop this contact or stop this coil, double tap and 1 and 1 and set, and double tap and 0. So that's it. That's the IO addressing. Now let's go for the timer. So I'm going to place another contact. Before that, I'm exiting from the simulator, exit from work online simulator, and now I'm on the edit mode. I'm going to just place a contact right here, and that will be I'm addressing as 2. 1, 0 and 1 I have already used, and I'm going to place one instruction. Here I can see place the instruction blocks placed here, and I'm going to search for the instruction. First thing, we are going to the timers. So I'm going to hit the find instruction, and you can see all the types in the groups, and these are the available instructions. I'm going to see the timer or counter instruction selection. Timer I just selected, and you can see the TIM, that is the 100 millisecond timer that I am going to use. So hit OK, and you can see the operands. Operands are 1 out of 2. I'm using the first operand will be the timer number starting with the T alphabet. You can see the first timer will be T0, so I'm using T0. So next I'm clicking on the second operand. The set value should be related with 100 milliseconds. So if you want to get the 10-second delay, I have to use the hash 100. So 100 multiplied by 100 is 10,000. That will be equal to 10,000 milliseconds. That will be equal to the 10 seconds. So I just also have to hit the OK button, and that has been appeared over here. And the timer number is 0, and the set value is hash 100. It's a BCD type timer. And I'm going to place one contact below, right below on the next rung, and that name it as T0, and hit enter. The T0, the output for the timer contact has been appeared, and I just want to place the appropriate coil for it. So the coil address will be 101, and hit OK. Okay, so that's it. So we can again hit the simulation. Now we are in the simulation mode and we can watch the progress by double tap and enter. You can see the value. I'm going to set the value over here, double tap, and the value will be 1 and set. You can see the timer is running. After 10 seconds we will be getting the T0 output. That is the timer we are using in the Omron. You can see. And after that we are going to the counter session. And for using the counter, I'm going to place one contact. That will be 3. I'm using I0.3, and that block will be, I'm going to see from the find instruction. You can go to watch the timer and counter from here, and the thing is CNT. You can see it is the counter, and hit OK. As the timer, there are 2 operands also. First thing is the counter number, so starting with the C. So I'm using C0. Next thing, I'm using the set value. Set value I'm using as hash 3 or 4 or hash 4. After 4 counts, that will produce the output. So hit OK. So the counter has been placed, and I'm going to hit the escape button for removing all this or changing it to the cursor, normal cursor. So that complete, and I'm going to place another contact. That will be the output of the counter, that will be C0, and placing on coil also, that will be 102, the third output. And I have to place one more contact right here because it is the reset for the counter. It is vacant in here. That I have to use one more contact, that will be I0.4 or 4 I have to type, and have to draw this control right arrow. That has been completed, and going to the simulation mode, and everything is okay. Then I am going to run the controller. I have to double tap and hit 1. You can see that has been reset or set to the positions, and I'm going to set 0 for this, and I'm going to increment the counter from here, double tap and 1, enter. You can see it is decrementing from 4 to 3 to 1, like that. Again I'm going to set it on, set it off and on. See, when reaching the 4th count, that will be getting the output. For the count, we have to use the set for the counter, and that's the working of the counter. And we can go for the hitting the next instruction by going back to offline mode. So I'm deleting all these things, previous runs, and I can go to put another contact right here, and we can explore some more things. That will be, first contact will be 0. And have to explore some more things in these instructions. Go to details and go for find instruction, and Arithmetic, Increment or Decrement, subroutine, subprogram, timer and counter we already gone through, and we can go for the addition or the arithmetic box. You can see the arithmetic operations over here as a group, and you can see these things also. These are the addition block. You can see signed, binary, add without carry. That is the arithmetic operations that we are going through next. First thing, that is the multiplication. So let's see how an arithmetic process or an arithmetic thing can be done in this Omron. So just hit OK. So we have 3 operands. 2 things will be the 2 things to be multiplied first. So I'm using W0, a word 0. W0 I'm using as the first operand, and I have to click this configuration button, and you can see that will be type will be integer. If you want to change it to anything or real or double word or real anything, you have to change it over here. So now I'm using the integer. So hit OK, and I'm going to use the W1. W1 as you can see also integer, and the output will be at W3. So that's it, and hit OK, and you can see we got the multiplication block. And let's see the progress for getting the runtime. Go hit the simulation, and I just double tap and make the block on first, and we can go for the watching the tables or watching the values. You can go for to hit the toggle watch window. You can see over here toggle watch window. So I have to click this, and a watch window will be appearing here, and double tap over the watch window, and I'm going to name the address. We need W0 as in the name of integer, so changing it to the integer and hit OK. So we have the W0 over here signed, and the value is over here, and the binary value is over here. And for getting the next corresponding memory, I have to double click here, just for double click, and automatically the suggestion W1 will be appeared here as in the name of or as in the data format as integer, and hit OK. Now we got W1, again W2. That's it. So now we have to the time for giving the values. I'm just giving the new value as 20, and set value. I have to give the set value. So it's plus 20 multiplied by 0, it is 0, and I'm going to make it as 5. 20 multiplied by 5, we are getting the output as 100 in the W3, W0, W1, and I'm using the W3, not W2. I'm using the W3. W3, hit OK. You can see it is 100. Sorry about the W2. I just used the W3. And that's how we doing in arithmetic process. And we can go back to the simulation or the edit mode, and I'm changing the block to another one. So pricing thing, go to detail, find instruction, and here we can choose all the arithmetic operations from here. Arithmetics can be done by everyone, and we can go for the logical operations. So in the logical operations we have the AND operation. First thing, double logical AND. I'm not using the logical AND word. I'm just using the logical XOR or double exclusive or word. That's I'm going to use, and hit OK. Or also 3 operands like that I'm using W0, and I'm not changing it to anything, just it's not a channel, have to use it as an integer. And W1 also have to make it as an integer, and W2. Now this time I'm using the W2, not W3, and hit OK. Okay, so we are using the normal arithmetic, not an arithmetic block, it's a logical block. So we have to monitor all these logical things in the binary format. You can see all this binary will be over here, and I'm going to make one of this thing on. So double tap here and edit or address, and you can see the binary option here. So you can check the binary height here, and you can see these things. Have to click anything to change as a binary, select it, and you can see to change the value, you can see the J. Have to change the value, have to hit the J, and by pressing the J you can see that will be in green color. I'm changing these things totally default, and hit the close button, simply hit the close button, and you can see the corresponding values will be loaded over here. And next thing, the next operand will be W1. So in the W1 I'm using nothing, I'm just giving nothing, or I can put any values. Go to binary and change these things by pressing the J. By changing the binary values, you have to keep in mind that you cannot turn this block on during this changing to binary, otherwise that won't work. Only the numerical values will be working whenever the contact is on for the block. And close this, and also that has been placed, and now we can really head back to the previous position or the runtime. So I'm making it on by pressing 1 and set. Now the block is on, and you can see the output right here. 0 0 XOR, it is 0, 1 and 0 XOR, and we are getting 1, 0 and XOR, we are getting 1, 1 0 XOR, we are getting 1, 0 0 no output, 0 1 output, and 1 0 we are getting also output. That is the way of we are getting an output from the XOR word. Like that we can get the OR and like blocks. OR and are very easy. OR means any one of the input will be getting the output, and means two of the inputs required for the output. And next thing we are going to learn, that will be going to find increment or decrement. During this increment and decrement we will be learning the rising edge contact. So this will be the binary increment, and hit OK. And in this only one operand will be right there. So I'm using W0. In W0 you are only using one operand, that will be an integer. Okay, and okay. So this is my increment block, and let's see what if I'm using the normally open contact in an increment block. Let's go to the simulation first, and I'm going to start this controller or start the contact. You can see it is incrementing in every 100 millisecond. It is incrementing by some values. So it is reaching up to 65,000 is the total value of then 16-bit word register, and it is again ramping up and down, up and down. The block is keep incrementing it. So there is no control with us, because it is exponentially increasing the value when the contact is on. That's why we are using the rising edge contact. You'll go hit back to the edit mode and change the contact to the rising edge. To make it as rising edge, you can right click over here, and you can see differentiate into up. You have to use the differentiate into up. So by using this rising edge contact, will be one pulse will be executed at a time. So there is no continuous feed or continuous sleep. One pulse will be executed at a time. So let's see the difference, and you can see when I am triggering this, set it as on, only one will be incrementing. I have to again go make it off, and again have to set it as on for getting the second trigger. So that's why we are using the rising edge for the high speed controlling, or the high speed feed controlling. We are using the rising edge trigger. So that is the increment block, and you can quickly go to the next one. So in detail, go to find instruction. Increment and decrement is okay. So we can go for the subroutine. So in the subroutine I'm not using right now. I'll be making another video for the jump and subroutine program control. And these serial control things we cannot move. We can go for the data move and hit OK. So two operands, one source and another one will be the destination. So for the source I'm using W0. It will be integer, sorry, not double integer, hit OK, and this will be W1 and also an integer, hit OK. Okay, so it's great, and I'm going to change it to the normal block, so differentiate into none, so it will be a normal open contact. So going to the simulation, now you can see the move block, whatever is in the source that will be moved to the destination. So I'm changing the value to 22 and set value. So 22 has been fed to the source word, and when the input contact is on, we will be getting the output in the W1 or whatever the output has been or the destination has been assigned. So that is the move block, and I'm going to delete this thing and search for another block that can be used for the basics. In this you can see floating point operations over here. You can see the floating point. I'm going to use the floating point multiplication over here. Click here and have to use W0. For using W0 have to use the real. To use the real, that will be by default, that will be as real, and I cannot use the W1 or W2. I have to use the W2 here. W2, that will be also real, and the output will be W3, and hit OK. I'm not changing it to anything because that will be by default, that will be real. So W0, W2 and W3, and have to use the integer, the type of data have to change during the simulation. And after reaching the simulation, you can see integer, the type of data I cannot, or the address type, that will be integer. I have to change it to a real or floating point, and hit OK. Here also W2 is edit the address type and change it to a real, and I cannot use the W3 in the block. Also have to go hit the block again, double tap on the block again, and sorry about this, double tap on the block again, and I am changing it to W4. I just change it, and 0 to 4, because we are used sometimes that real numbers will take 32-bit memories, so we have to assign the W0 and 1 for the first one, 2 and 3 for the second one, 4 and 5 for the result. So W4, that will be also a real. If you want to get the long real, you have to use that also. And W0 I am using as 2.5. I'm using it here on the W2, and for the W1 and 2 I'm using 2.5 and 4.0. The 0 will be fed by default, and by triggering the contact, you can see the output set on. You can see it is 2.5 multiplied by 4.0, that will be 10.00. Some values will be also fed to the W5 and or 6 also. So the W6 I'm using, sorry, W5, if I am watching the W5, some values also will be fed to the W5 because it is taking the 32-bit values for storing the results. So that's it. So hope you enjoyed the Omron tutorial. So stay tuned to watch the other videos by YouTube. So if you like the video, please hit like and subscribe. Thank you.